In this video, we're going to work on the ALEKS problem called Identifying Constitutional Isomers. This problem is going to provide us with a molecule and then an additional 4 molecules, and it's asking us to check which of these 4 molecules are constitutional isomers of the provided molecule. So we need to start by defining constitutional isomer. Constitutional isomers are molecules that have the same molecular formula, but they need to have different connectivity. That means that the atoms are arranged in a different way. So when I'm looking for constitutional isomers, the first thing that I like to do is just check the molecular formula. In order for them to be isomers, they need to have the same formula. That means the same number of carbon atoms and the same number of hydrogen atoms. And the molecule that's provided to me, let's see how many carbon atoms I have. 1, 2, 3, 4, 5, 6. So that's a C6. And first thing that I'm going to do before I even count hydrogens is check these molecules right here and see how many carbon atoms they have. If any of them have more or less than 6 carbon atoms, I know that it's not an isomer. This molecule has also 6 carbons, so it's possibly an isomer. This has also 6 carbons, so it's possibly an isomer. It doesn't mean that it is, just maybe. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So these all have the same number of carbons. Next thing that we should do is check the number of hydrogen atoms in the molecule. In the molecule provided to me, I'm going to sketch in my hydrogen atoms using what I know about the way carbon likes to bond. Every carbon likes to have a total of 4 bonds. So that means that if I can only see 2 bonds in the line structure, that tells me that I've got 2 more hydrogens. This molecule has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. C6H12. I'm going to go back through these molecules and see how many hydrogen atoms they have. If they don't have 12, that means that they are not a constitutional isomer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this first molecule has the same formula. It's possibly an isomer. Second molecule, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's also same formula, so again, possibly an isomer. It's not guaranteed to be an isomer, even though it has the same formula, because we're going to have to go through and look again at the connectivity. Last 2 that I have on here, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we haven't been able to eliminate any of them yet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So all of the molecules in this problem, all 5 of them, have the exact same molecular formula. That means at this point, they're all possibly isomers of the provided molecule. The next thing that we need to do is check the connectivity. Now, in order to check the connectivity, I'm going to erase all of this drawing that I did just to make it a little bit easier for us to visualize. Different connectivity means that our atoms need to be connected together in a different way. So in the molecule that has been provided to us, we have a pattern of having 5 carbon atoms connected in this. We call this a ring shape. Even though it's not a circle, we refer to it as a ring. 5 carbon atoms in a ring. This molecule here does not have a 5-membered ring. No rings at all. So that means that this molecule definitely has different connectivity. There's a different pattern in which the atoms are arranged. So this is absolutely, yes, an isomer. And the molecule that I skipped over, this one, it is also a ring, but this is a ring that contains 6 carbon atoms, not 5. So that is also a molecule with different connectivity. That's also an isomer. And these last 2 that I have down here, these are going to be a little tricky. Both of these are molecules that have 5-membered rings, just like the one that has been provided to us. And the 5-membered ring has another carbon atom sticking off of it like that. All three of these molecules have the exact same connectivity. They all have their atoms arranged in the same way, 5 in a ring with 1 sticking off. Now they have different orientation, meaning that this one is pointed in such a way that the blue line is sticking straight up, and this one has been tilted a little bit so that the blue line is off to the right side, and this one has been tilted so the blue line is off to the left, but that does not change the connectivity of the molecule. So this molecule is the exact same thing as this molecule, which is the exact same thing as the provided molecule. These are not constitutional isomers, they're just identical molecules.